Hi everyone. In this video, we're going to look at the ratios, rate, and proportions. We have 5 objectives. First, we're going to look at the rate and the ratios and write them in the simplest form. Then we look at the unit rate. And also in the end, we are looking at how to make decision which one is better by looking at the unit price. So let's look at them one by one. So first, ratio. Basically, ratio is comparison between two quantities using a quotient. So we know quotient is the result of division, right? In other words, we can use division to compare two numbers. For example, between 6 and 2, we can do subtraction to compare them. 6 minus 2 equals 4, right? Then we can say 6 is 4 more than 2. So that's comparison. At the same time, we can also use division to compare those two numbers. 6 divided by 2 equals 3, right? So what does that 3 mean? So 3 means 6 is 3 times as big as 2. So that's comparison 2, right? So when we use a ratio to compare two numbers, we can use this colon notation. That means it just uses colon mark in between two numbers. It's like those in the in sports scoreboard, on the scoreboard, right? You can also write ratio in this fraction format. Now let's look at our first example. The pitch, which is also called the degree of slant of a roof, is to be 8 inches of vertical rise for every 12 inches of horizontal length. So write the ratio of vertical rise to the horizontal length in simplest form. First of all, when we write ratio, we always put the first number mentioned on the top, second number on the bottom. So this is about rise to the horizontal length. So rise is 8 inches. The horizontal length is 12 inches. So these two cancel. In other words, when you write ratio, we assume you're going to have same units. That's why sometimes we don't even bother to write these two units yet because they are the same. In case they are not the same, for example, if one is in inch, the other one is in foot, you have to do some conversion so that they have same unit. Doesn't matter which unit they have, but they need to have same unit. So simplify it, both number can be divided by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. That's a 2 to 3 ratio. So that's it. That's the solution. Now let's look at our second example on the second page. For every 2.5 rotations of the pedals on the bicycle, the back wheel rotates 3.25 times, 3.25 turns. Write the ratio of the number of pedal rotations to the number of back wheel rotations. So the first one is pedal rotations. That is, let's use the R to represent this ratio. So pedal rotation is 2.5, and the back wheel rotation is 3.25. So apparently these two are mixed numbers. So in order to compare them, in order to do division using mixed numbers, we need to convert each of them to the improper fraction, right? So the way to do that is multiply these two numbers, add to the number on the top. So that's going to be 5 over 2. 12 plus 1 is 13, 13 over 4. So now let's do this fraction division. 5 over 2 divided by 13 over 4. So we all know how to do division with fractions, right? So we keep the first number unchanged. Doesn't matter if it's a fraction or not. And change division to multiplication. And at the same time, we want to switch the second number. Now, when we multiply fractions, we don't just multiply them straight out. Say 5 times 4, 2 times 13, right? The reason is that after you multiply them, you still need to simplify them. You get a bigger number to simplify if you multiply them first. So you bring more work to yourself, right? So instead, we want to simplify them before we multiply them. So between 2 and 4, both can be divided by 2, right? 2 divided by 2, 4 divided by 2 is 2. So now there's no number that can be simplified between number from the top and number from bottom, right? Now it's time to multiply them. 5 times 2, that's 10. 1 times 13, that's 13. So that's a simplest form. That means for every 10 rotations on the pedal, there will be 13 rotations on the of the back wheel. Now, next example. Apparently, this time we have decimals, but other than that, pretty much the same kind of problem. So the diameter of a piece of pipe is 0.42 meters, and the length is 3.5 meters. Write the ratio of the diameter to the length in simplest form. In our ratio equals, the first one is 0.42. They're all in meters, so we don't need to write the unit. Now, this cannot be the final answer because a fraction by definition is composed of two numbers, two whole numbers, one on the top, one on the bottom. They are not whole numbers. So we need to move decimal point to the right two places. Here, we have to move, by the way, we have to move the same number of decimal digits in order to keep this value the same. So both need to move two decimal places. 42, there's two decimal places, 350. Now simplify that. Divide both sides by the same number. At least we can see both are even numbers. Both can be divided by 2. This is going to be 21. This is going to be 175. Now, which number to divide by then? If you're not sure, try this three numbers. If they're even number, can be divided by 2. If ending with a 5 or 0, can be divided by 5. But this is not the case. This one can be divided by 5. This one cannot. So 5 doesn't work. How about the 3? If the sum of digits can be divided by 3, then that number can be divided by 3. So 2 plus 1 is 3. 3 can be divided by 3. So 21 can be divided by 3. But if we add these 3 digits together, it's 13. 13 cannot be divided by 3. So 3 doesn't work, 5 doesn't work, 2 doesn't work. So what do we do then? You always try prime numbers, because all of the composite number can be factored into prime numbers in the end. Factors are divisors at the same time. Prime number means a number that can only be divided by 1 and itself. So we tried 2, we tried 3, we tried 5. They're all prime numbers. They don't work. So what is the next prime number? 7. 7 can only be divided by 1 and itself. 21 divided by 7, sure. How about 175? Let's try that. Let me turn the light on my camera. Much better. That work out? 25. So we divide both sides by 7. This is 3, this is 25. So we simplify it. This is the final answer. Now, next topic, determine probabilities. Actually, it's a theoretical probability. Now, this is definition, or this is also, you can call it a formula, theoretical probability of equally likely outcomes. That means to use this formula, we assume all of the outcomes have equal chance to come to be true, to realize. For example, if you toss a die, we always say a fair die, right? What is a fair die? That means all of the 6 numbers on the die have equal chance to show up on the top. So how do we do the calculation then? It's the ratio. The probability of a certain event is the ratio of the number of favorable outcomes. That means how many outcomes are favorable to the total number of possible outcomes. So let's look at this illustration here. Suppose you toss a coin, right? We all know coin has two sides, head and tail. Almost forgot that word. Head and tail. So they have equal chance to show up. So the number on the bottom is the total number of possible outcomes. Sure, you only have two sides, you have two possible outcomes. How about the desired outcome or favorable outcome? Since we're looking for a head, there's only one head on the coin, right? So that's one possible outcome, one desired outcome. So the number of favorable or number of desired outcomes on the top, the number of total possible outcomes on the bottom. That's how we calculate the theoretical probability of a certain event. Now let's look at example 4. Determine the probability. Write each probability in the simplest form. That means reduce your fraction to simplest form. A, what is the probability of rolling a 2 on a 6-sided die? That means those 6 numbers, 1 through 6, right? Since they have equal chance to show up, so the formula, we want to have 2, probability of getting a 2, right? The formula is a total number of possible outcomes on the bottom. We have 6 possible outcomes. How many among those 6 possible outcomes are the ones that favorable? That's the ones that we want. We want 2. There's only 1 2 on that die. So the one favorable outcome. Number of favorable outcomes on the top. The total number of possible outcomes on the bottom. Now B, what is the probability of getting a 7 on a die, 6-sided die? We want to get a 7, the number on the bottom stays the same, 6 possible outcomes. How many outcomes among those 6 possible outcomes are 7? There's only 0. There's no this number on the die. So you have no chance. Now C, what is the probability of tossing a 1, 2, 3, 4, 5, or 6 on the 6-sided die? That means any one of the 6 numbers are okay, are favorable. We want any one of those, doesn't matter. So we want to have a 1 or 2, just continue until we reach 6. So there are 6 possible outcomes. What we want any one of those is okay, 6 desirable outcomes. So that's 1. In probability, a value of being 1 means it's destined to happen. It will happen no matter what. So you want to have one of the 6 numbers. Guess what? It will happen. That's the meaning of being 1. D, what is the probability of drawing a red king out of a standard deck of 52 cards? First of all, pay attention to this wording. We want to have a red king. In other words, this is 1 card. We want to have 1 card. That's important because the formula says the number on the bottom is the total possible number of outcomes. If you just draw 1 card, you have 52 different cards in a deck of cards. Sure, you have 52 different outcomes. But if you are selecting 2 cards, that number is way bigger. We don't learn it in this course, but that number is way bigger on the bottom. But at the same time, the number on top should be desired one. We want to have a red king. How many red kings are in a deck of cards? 2 of them, right? 2 of them. So simplify it, simplest form, that's 1/26. That's your chance. 2 red kings. Now, let's look at the next topic or next learning objective, unit ratio. A ratio in which the denominator is 1. So these are ratios. We've been working with ratios, several examples, right? These are ratios, but it says denominator is not 1. It's just a typical ratio. Now, here is an example. A debt to income ratio is more informative when expressed as a unit ratio. Let's say why it is so. Suppose a person pays $200 towards debt out of every $1,000 of that person's income. Then we can write debt to income ratio. So always pay attention to the order of these two words. Debt first, income second. So this person's debt is 200, income is 1,000. They have to have same unit, by the way. So this is the ratio. This is it. Basically, if we want to simplify that, both can be divided by 200 is 1/5. So this really means for every $5 income, that $1 is the debt. Every 1 out of $5 is debt. So basically, this is a ratio. This is the final answer. But what is unit ratio? Unit ratio, this number on the bottom has to be 1. How to get 1? Just do division. 1 divided by, let's write it here. 1 divided by 5 is 0.2. Then how do we know the number denominator is 1? Because we can put 1 on the bottom of any number without changing the value of it, right? 0.2 divided by 1 still 0.2. So this means for every $1 of income, you need to pay 20 cents as debt. So this is in other words, it's just a do division. Whatever you get, that's unit ratio. That's very, very simple actually. Now, this is a description of how you would write a ratio into unit ratio. To write a ratio as a unit ratio, just divide by the denominator into divide the denominator into the numerator. Just do the division, in other words. Now let's look at 2 more examples. Write each ratio as a unit ratio and interpret the result. A family has a total debt of this amount and a gross annual income of this amount. What is this family's debt to income ratio? It's pretty much similar problem, just 2 different numbers. So we get debt 5,865. We get income 45,200, and that's it. For every 45,200 dollars income, and this family owes this amount of debt. So how about a unit ratio, right? To get a unit ratio, all we need is to do this division. 5,865 divided by 45,200. 0.129. If we round it to cents, it's because it's money, we round it to 0.13. Let me make sure my numbers are right. 45,200, that's right. So 0.13. So what does this mean? Remember, whatever you get after division, the denominator is 1. This is the income. So for every $1 income, this family, it owes 13 cents debt. So that's the meaning of it. Now let's look at B. A certain college has 9,752 students and 460 faculty members. What is the student to faculty ratio? So just put a student number on the top, faculty number on the bottom, and that's it. Maybe you can further simplify it, but this is the student to faculty ratio. But how about the unit ratio? Again, we simply do the division. 9,752 divided by 460 equals 21.2. Remember, the denominator is 1 always. What does this mean? For every 1 faculty, there will be 21.2 students. So you can see from this example, by using unit ratio, it's easier to digest, to understand the information. This one is hard to understand exactly the ratio, right? This one just tell you for every faculty, there will be a little bit more than 21 students. Or you say for every 21.2 students, there's 1 faculty. Okay, now write rates in simplest form. So not ratio anymore, it's a rate. So what's the rate between, what is the difference between a rate and a ratio? Ratio, they basically, for the 2 numbers, they measure the same thing. So for this one, we just did the measure people, both measure people. So for that pitch thing, the rise of the roof and the length of the roof is all measured in length unit. So they all measure the same thing. Now, what is a rate? A ratio comparing, we also compare two numbers by division, but these are two different measurements. It's not two different, say, in int and foot, that kind of difference. That's not difference. That's the same measurement, just in different units, same measurement. They both measure the length. When they say different measurement, they measure different things. Now let's look at the example here, example 6. An athlete is clocked running the 40-yard dash in 4.4 seconds. So look at this two. One is in yard, one is in seconds. They measure different things. One is time, one is the length. There's no way you can convert between the two. But between foot and inch, you can convert them to the same unit because they measure the same thing. So now the question is, what is the athlete's average rate in yards per second? So whenever they say per something, this thing is on the bottom because per second means per 1 second. It has to be on the bottom. Now let's look at the next page. Let's look at the solutions. How to do the calculation part. Now let's do it this way, right? Now solution, basically we put a yard on the top. This time you cannot cancel the unit because they measure different things. 40 yards in 4.4 seconds. Now we want to have the unit rate, okay? Unit rate. So we simply do the division. 40 divided by 4.4. 9.09. So if we take 2 decimal digits, when you do your homework, depend on the requirement. But for now, let's just take 2 decimal digits. This is the yards, this is per second. So this is how fast that person runs, right? 9.09 yards per second. That's unit rate. Now the last topic for us is to look at unit price. We can unit price is kind of unit rate, just in terms of price of goods. We can use this to make decision which one is a better buy. So let's look at this example. This is the yeah, we have 2 examples here. This first one says a 15-ounce box of cereal costs $3.56. What is the unit price in cents per ounce? So per ounce, that means ounce on the bottom. You need to divide by ounce using many units. This time is $3.56 divided by 15 ounces. Now pay attention, they ask us the price, unit price in cents per ounce. This is dollar. So when you convert dollar to cents, just 2 digits to the right, 356 cents, 15 ounces. Now we do division, we get per ounce, unit price. So 356 divided by 15, 23.7. If we take 1 decimal digit, usually if you look at the price in stores, they have 1 decimal digits, 23.7 cents per ounce. This is how you compare because from the next example, you're going to see usually the prices come in different weight and different dollar amount. It's very hard for regular person to compare, regular shopper to compare which one is a better deal. Instead, if you convert both into unit price, everybody can see which one is better deal. So let's work this out. First, you have 2 different choices here. One is a 15-ounce boxes of brand cereal. For this amount, the other one is 20 ounces. It's a little bit bigger box of same thing for a little bit higher price, $3.59. So which one is better? So everybody needs to make this decision, right? When they do shopping. So let's find out the unit price for each. So we just use the price divided by the weight. For this one, we we convert each one to, you can convert to cents or stay in the dollar. Actually, doesn't make any difference in the end. You will see the difference. Let's just stay with the dollar. They didn't ask us to convert to cents. So $2.45 for 20 ounces. The other one is $3.59 for, oh, I was wrong, for 15. This is 15. This is 20 ounces. Now we simply do division. Again, you don't have to convert to cents. So $2.45 divided by 15 ounces. Usually in the store is cents per ounce because most of them are in the cents. It's not expensive. If it's a huge dollar amount, you don't need to convert to cents. Just look at the dollar amount. 0.163. Let's take 3 decimal digits. 0.163 is the dollar per ounce. Now look at the other one. $3.59. 3.59 divided by 20. 0.179. This is 5. We round it up. Now it becomes 10.18. So this one is 0.18 per ounce. So which one has a higher price? So even though in dollar, you can see still 0.18 is bigger than 0.163. That means in real life, bigger package doesn't necessarily implies the better price. Sometimes it's decisive. So just need to do calculation. Because sometimes they just take advantage of people's perception that when you buy more, your price is lower because you buy a bigger package, right? So that's not necessarily true in real life. That's all for this video. See you guys in the next one.